Insol company presents the Phase-Coherent MIMO acquisition measurement system and the Phase-Coherent MIMO generation measurement system. These measurement systems can be used in the following fields: delay line measurement, active antenna array calibration, radio environment imitation. The measurement systems are designed for multi-channel phase-coherent RF signal acquisition and multi-channel phase-coherent RF signal generation. These measurement systems permit continuous record of the signal with 50 MHz bandwidth and playing back the signal with 100 MHz bandwidth, which can be used for recording in the electromagnetic environment and for further playback in laboratory conditions. Let's consider each system in detail. Phase-coherent MIMO generation measurement system. This measurement system is designed for multi-channel phase-coherent RF signal generation. Technical characteristics: number of channels, minimum is 2. Maximum can be modified up to the necessary number of channels. Frequency range: minimum 85 MHz, maximum 6.6 GHz by using RF vector signal generator 5673E, 12 or 24 GHz by using up-converter. Phase mismatch between the channels is less than 0.1 degree. Let's consider the phase-coherent RF signal generation. The left figure shows big-size chassis with vector signal generator, and the right figure shows the architecture of these generators. The phase-coherent RF signal generation is carried on the following way. Both baseband sample clock and the local oscillators are shared between the both channels. Now let's consider the phase-coherent MIMO acquisition measurement system. This measurement system is designed for multi-channel phase-coherent RF signal acquisition. Technical characteristics: number of channels, minimum is 2. Maximum can be modified up to the necessary number of channels. Frequency range: minimum 20 Hz, maximum 6.6 GHz by using RF vector signal analyzer 5663E. 7 GHz by using RF vector signal analyzer 5667. 14 GHz by using RF vector signal analyzer 5665. 26.5 GHz by using RF vector signal analyzer 5668R. Phase mismatch between the channels is less than 0.1 degree. Let's consider the phase-coherent RF signal acquisition. The left figure shows big-size chassis with vector signal analyzers, and the right figure shows the architecture of these analyzers. The phase-coherent RF signal acquisition is carried on the following way. Both local oscillators and baseband intermediate frequency signals are synchronized. Software. Software is developed in the LabVIEW graphical programming environment. Software consists of Phase-Coherent MIMO acquisition and generation toolkit, software for analysis, software for generation. Let's consider the Phase-Coherent MIMO acquisition and generation toolkit, PCAG MIMO toolkit. PCAG MIMO toolkit is a library of drivers which can be used for easy creation of different software solutions. Let's consider a program for analysis, PCAG VASA front panel. PCAG VASA front panel performs coherent acquisition and analysis of RF signals and records and saves the file after the acquisition process. Has the function of phase difference and amplitude auto-calibration. Has the ability to work together with tone converter. Displays the signal on various graphs such as IQ versus time, I versus Q, power versus time, phase versus time, phase delta versus time, power spectra. Open singleton generation software along with PCAG VASA front panel software. Select the following parameters. In generator, Frequency 1 GHz, power 0 dBm. In the analyzer, IQ rate 1 megasamples per second, power 0 dBm, number of samples 1000. Run the singleton generation program. We have specially introduced amplitude imbalance so you can see both signals. As you can see by selected parameters, the phase delta STD is 0.02. Mean phase delta is 0.2. So let's begin the calibration process. At this time in generator must be set the frequency 6 GHz. Power level 0 dBm. In analyzer carrier frequency 6 GHz. IQ rate 1 megasamples per second. Reference level 0 dBm, the number of samples 10,000. Run the program singleton generation. Go to the charts tab and choose the phase delta versus time. Set the value of 1080 and minus 1080. As you can see, the curves of phase difference is moved to minus 19.2. Let's carry out the calibration process. If you want to calibrate channels in pair, set the channels parameter 0,1 and so on. If you want to calibrate all channels, set -1. Again, change the value to 1080 and minus 1080 and press the bottom after calibration. As you can see, the curve is shifted to 0. Change the value to 0.3 and minus 0.05 and see how the phase difference varies near 0. Now we will show why we have introduced the amplitude imbalance. Set IQ phase offset to 0. Go to the charts tab and choose IQ versus time. As you can see, the signals are offset. Let's calibrate them. Click the calibration tab and make the same calibration procedure as before. As you can see, after the calibration process, only one curve is visible. Let's consider the software for generation. PCAG-VSG front panel. PCAG-VSG front panel performs coherent generation of RF signals and continuous waveform signal generation, arbitrary waveform generation, generation of signal with parameters read from the recorded file. For more information, visit our website insol.am.